Now, when we take a look at 8-bit unsigned numbers, what we're really talking about here is 8-bit unsigned char, because that's one of the data types we're going to be using in C. And if we put all of our hex numbers from 00 to FF on the top and the decimal equivalents on the bottom, we're going to see that we have 0 to 7F, which is 0 to 127. And the way we figure this out is 7 times 16 plus 15 is 127. 16 goes into 127, 7 with 15 remainder. And again, we have 80 to FF here. 80 is 8 times 16, which is 128. 16 goes into 128, 8 times with 0 remainder, all the way up here to 15 times 16 plus 15 is 255. 16 goes into 255, 15 with 15 remainder. So we can see that that conversion that we had from hex to decimal and decimal to hex works across the entire 8-bit unsigned numbers. But we also have something called 8-bit signed numbers, and it's a little bit different. And you're wondering, well, why do we have a difference here between this 80 and this FF and this 80 and this FF? We're going to find that if we look at the most significant bit of all these numbers, the most significant bit of all the numbers in hex from 0 to 7F is n equals 0. N is really the most significant bit, so n equals 0 for this side here, and these numbers here, as you can see, are positive. For all the numbers from 80 through FF here, n equals 1, because the most significant bit of 8, A, B, C, and so on to F is 1. But again, the numbers here are positive. So all the numbers here for 8-bit unsigned char, all the numbers are positive, and the n bit, it doesn't matter whether it's a 0, doesn't matter whether it's a 1, these are all positive numbers. But if we take a look down here, we've got n equals 0 here, these numbers are positive, and we've got n equals 1 here, these numbers are negative. So for 8-bit signed char, half of our numbers are positive where n equals 0, half our numbers are negative where n equals 1, so it splits them into two equal camps. And you're kind of wondering, well, why do we need these two different number systems? Well, microcontrollers are great at digitizing. Even when you talk into your cell phone, the waveform that goes in is analog, but once it goes in, it becomes digital. And if you have voltages from, say, 0 to plus 10 volts, it would make sense to have decimal numbers 0 to FF being represented here as all positive voltages. But sometimes you might have minus 5 here and plus 5 where you've got 10 volts again, but half your voltages are negative and half are positive. In this case, you would need 8-bit signed char where half your voltages are negative, half your voltages are positive, so your numbers are going to reflect that. Now, one of the things that you'll note is this 80 to this FF, the 80 here, which is 128, to this 80, which is minus 128, this 80 to this 80 has been offset by 256, which is 2 to the 8th power. In fact, all the numbers from 80 to FF are offset by 256, and this is going to be important later, as we'll see.